Okay, Ganesh, carry on.
Hi, good afternoon to all. I am Ganesh Kumar, Creative Volunteer, and now I am here to give introduction about Creative and welcome to our today's speaker. Creative, we are a group of individuals with like-minded interest in promoting the knowledge amongst the curious minds. The Creative is a source of inspiration for the knowledge and activeness in strength of the spreading the knowledge. The secret behind any successful stories would be the way the knowledge is constructed from the right age. We hope to provide that to every curious minds appropriately. And today our speaker is Dr. Balakrishnan Manikyam sir. Took doctoral degree in physics from IIT Madras. He joined Indian Meteorological Department and worked for 6 years. Later he joined ISRO. He worked in the satellite remote sensing program and coordinated the setting up of the National Natural Resource Management System in the country. He played a key role in the developing several indigenous weather instruments such as automatic weather station, GPS sound, and LIDAR, and establishing network across the country. Dr. Manikyam sir worked as an expert in remote sensing GIS at the United Nations office in Bangkok and has visited several countries to advise on satellite applications. After retirement, he pursued teaching at postdoctoral level in physics, satellite applications, and meteorology. He was appointed as a Sir M. Vishwesvaraya ISRO Chairs Professor in Bangalore University, and he contributed to development of academic and research activities related to space and atmospheric science. Presently, he is visiting professor in Bangalore University. He has published over 150 research papers in field of satellite applications and meteorology. Today, Dr. Manikyam sir will be talking on the theme of satellite remote sensing and science and applications. Welcome, sir. I welcome one and all. Thank you, sir. And over to Manikyam, sir. Thank you.
Thank you. Shall I talk now? Shall I start?
Okay, sir. You can start.
Yeah. I am Balakrishnan Manikya. I had the good fortune to work in the Indian Meteorological Department, which is talking about weather forecasts and all that. And then also in the Indian Space Research Organization. I'm very happy to talk to the members and participants of this nice program, Create Active. Yes, this is a very good way of reaching the knowledge to several people, interested people and students, faculty and all that. So I wish very best for the creative group. Let them grow much, much more with many chapters in other states also. So basically today I will be talking to all of you about the climate change causes and effects, and especially what way the satellites have helped in identifying these parameters, how we could actually find out whether really a climate change is happening or is it just a talk, no, a gossip type thing. And then when the climate change is happening, what are the things we should worry about and prepare as a humanity, how prepare for future. So this has happened several times in the history of the world. Especially you would have heard about the dinosaurs disappearing suddenly, then particular species of living things totally disappearing from the Earth's surface, basically due to changes that happen in the weather and climate. The dinosaurs, what they are talking about now, after a lot of research, is something fell, some very large sized comet like thing fell on the Earth at that time, and that created a lot of dust and other particles which spread in the atmosphere, changed the whole weather, and the whole world, many of the living systems could not survive further because they need radiation, they need food, they need vegetation. All these things got affected because of the change in the weather. So weather plays a very important part, and I will be telling you in future in my talk how it is organized over our earth and how it is changing. Next slide. Yes. So whenever two people meet, you know very well, any human beings, any ladies or gents, whoever it is, the first thing we talk is, oh, it's very hot, very cold, it is raining, it's very moist, something or other about weather. So weather is actually like our, a family member, I should say. We keep on talking about the weather, and with nothing can be done about it because whatever weather comes, we have to accept it and do it. But still, a lot of discussion is there about the weather, and basically, we also discuss the likelihood of what the next few days going to rain more, it's going to be very hot. So these type of concerns are also there because weather is an important parameter in the human life or any life for that matter. Suppose a continuous days of 15, 20 days of cloudy days, even no need of rain. Cloudy days is enough. A large number of, type of diseases will spread. The diseases for those germs and all that, this weather is very good. So they keep germinating, increasing in number, affecting the human. Suppose it is very hot waves, then it affects us directly, removing the water, the amount of water in our body, making us more dry, and all our systems will be working at much slower pace. And if it is highly too much of rainfall, that also is not good because most of the agriculture will be washed away. A lot of losses will be there. So that way, the weather plays a very, very important role in our overall life. Next one. And most of you know what is weather and all these things that's happening. Weather is actually what is happening at this point of time. At this point of time, if you take the atmosphere, whatever is happening in the atmosphere is the weather. So in a scientific term, if you want to define it, it is like our mind. See our mind, whether it's happy or sorrowful, or between these two things, like that. Or we are very lazy, we want to sleep. These are all the different states of the mind. But it's decided by a number of parameters in the brain and all that. Same way, weather also, there are a number of parameters in the atmosphere, which it decides what's the weather at that point. Next slide. Yes, what is climate then? See, weather is to be understood what is happening now at this point, or for example, a day. In a day, what has happened, we can call it as weather. Now, over a period, what happened, let us say 50 years of data, what you will find when it comes June, the rain starts, the monsoon rain, and it continues up to September. Again, October, nothing will be there. December to January, there will be another set of rain. So, slowly, a sort of pattern emerges in the weather. Anywhere in the world, there's a pattern of weather over that area, and that is called as climate. For example, what they say, the Bangalore climate is very good. Whether what they mean is, it is not that all the days it is good. Most of the days, that's why the word climate is used. Climate is like an average. So when I talk something about climate, it is an average of so many years. And the basic definition of science says 30 years. Minimum 30 years of data you should have taken to tell this is the average. So I can call this is the climate of that area. So with respect to climate, you can talk about the maximum temperature, minimum temperature that will happen, then the amount of rainfall that will happen. Okay, like that, and wind conditions and all that things. So why this is required? Basically, all our systems, if you talk about agriculture, production, transport, even our, what they call as the festivals, everything is dependent on this climate. If the climate changes, everything has to change according to that. For example, the farmers, what they do, they look for that particular time. Okay, next 2-3 days, rain is going to come. Then they start the process of tilling and all that, getting their things ready and keep the seeds ready. And then little spraying of water. And then they put the seeds in the hope that next 2 days rain will come. And when the rain comes, the seeds grow and fertilizes and grows and like that. But suppose the rain doesn't come, even after 2, 3, 4 days, then all these seeds will wilt. Actually, they will dry and they will lose the crops. This is what happened in this year. I'll talk about this year specifically a little later, and all that. So basically, what happened? Climate is our expectation, really speaking. What is the likely weather that can happen these months? That is climate. And any changes in that is an indication of a major changes happening in the weather. Not for 1 or 2 days. See, when I say climate has changed, that means for 30-year average has changed. Kindly understand that, all your scientists. Basically, a 30 years change only is prescribed as the climate change. So now we can understand the seriousness of the things. It is not that last year there was no rain, so climate has changed. No, I cannot tell that. It has to change from the normal routine pattern, at least for the 30 years period. So how the satellites and other things are helped in this type of studies is what I am going to talk about. Next one, next slide. Next slide. Yes. Now you see our Earth and the atmosphere. Very, very interesting, actually. Actually, Einstein was asked, Albert Einstein, Nobel laureate, who discovered so many things. And the most difficult thing is the relativity theory. Even today, people have not understood it fully, how the time comes into the equations. But he could at that time itself visualize, a very big scientist. He was asked, what are the fields which you may not like to work in? He said, there are two fields which I don't want to do anything with. One is politics, he said. Politics is so, so much changing with time and dynamic. Nobody can work. There's no science in that. The second one is atmospheric science, he told. See, such an intelligent person, he forecast about it. That studying with the atmosphere is very, very difficult, very complex. So it will be very difficult to study that. Now let us see the Earth. You can see a picture, part 1/4 of the Earth only. These are all satellite pictures. Now you can see the whole Earth from the space. You can see Bangalore. You can see houses. Everything you can see. I will be showing you all those things. Exciting scenarios coming slides. Now you see the whole atmosphere is nothing but as thick as the skin of the apple. You see the skin of the apple, we eat also, no? It's so thin. Some people peel it off and eat, otherwise take it as it is. Basically, it is that thickness only when you compare with the total Earth. So it's such a small thing, but that is controlling the entire Earth's climate and weather. That is the interesting thing. Such a small, like actually our atmosphere is about 50 to 60 kilometers only. Up to 50, 60 kilometers only, you will see any molecules, atoms, and all that. After that, it is all vacuum. So this thing is changing our entire weather and climate. It has produced the entire weather and climate. I will just give a quick comparison of the moon. Recently, you're all aware, ISRO has succeeded in launching and reaching the moon and also putting a lander there. Which is taken a lot of data and given to us. So basically, the moon has no atmosphere. And with that, how it looks like, you tell me. The moon has no atmosphere and there is no weather also. The highest temperature is minus 265 degrees. Lowest temperature, minus 265 in the daytime. In the night time, daytime, it is plus 265. It's just the sun goes on heating it and cooling. And remaining time, it gets cooled off because of the radiation. So just heating and cooling, very difficult to live there. And there is no living things. So it cannot support any life there as of now. The future we have to see how we can modify it and all that. But basically, between the moon and the earth, there's a big difference. Just an atmosphere has caused such a beautiful earth for us with a lot of water, a lot of winds, a lot of other conditions. Next one, next slide. Okay, see how it has happened. Interestingly, you can see the Earth. Earth is actually, you can see, I just put a circle over there, and it's not that big compared to other big planets like Jupiter, Saturn, and all that, but they are all very far away. See, as they go far and far, far away, the radiation they receive will be that much less, very less. Actually, whatever sun's radiation is coming, the highest is received by Mercury, then Venus, and then Earth. But in this Mercury and Venus, there is no living systems. Possible, mostly, because the temperature is so high. And comes to Earth, our average temperature is 15 degrees centigrade. Thermodynamically, if you calculate, all the ice, and all that, all the hot areas, deserts, everything, if you take an average, it is 15 degrees centigrade. Most ideal for supporting the living systems. So this is a very important thing, that we are that much far away from the sun. and we are also having the atmosphere. Next one, next slide. Okay, now this particular weather, for example, if the earth was actually perfectly oriented with the sun, what I mean is the earth axis, the rotation axis is perpendicular to the sun. Suppose it was like that. Then one side of the earth would always receive perpendicular rays, and another side will receive perpendicular rays when sun goes the other side. You know very well, every day we are rotating. So out of 24 hours, 12 hours we will face the sun. Another 12 hours, another part is facing the sun. So both would have received equal amount of radiation, but that is not the case to be. From the development and how the earth is placed is 23.5-degree inclination. That is our axis of rotation is 23.5-degree compared to the sun's movement. So with this very important thing is some part of the latitude will receive very high radiation, like the tropical areas, what we call as 20 degree from the equator, both sides, north and south. And India happens to be much within that. Not many countries you will see. If you see the whole globe, very, very few countries have got so much major part of their land on this area, tropical region. That is why we are having high rainfall, monsoon, and such systems, cyclones. All these things are happening because we are receiving the highest rainfall from the highest radiation from the sun. So this is almost like a Carnot engine, I would say. A Carnot engine, how it works? Petrol is there, it is burnt, and the explosion moves something like that. The same way here also, the radiation coming from the sun is our engine. The whole Earth system to be having energy is only from there, no other source. Because within the Earth itself, we cannot create any energy. Whatever it is having, permanent actually. But the radiation which comes from the sun is giving us every day so much kilowatts of energy. And that energy slowly heats up the atmosphere, makes clouds, heats the ocean, and finally, a lot of clouds are formed, and weather and all this is formed. So this phenomenon of weather is not there in many of the planets. Many of the planets in the whole world or the whole universe itself, now they have found out an Earth-like system. How many, far away? About 250 light years far away. So if you travel in the speed of light, 250 years you will take to reach that Earth. Such a Earth they found out so far away. That means the entire universe also, a unique system like Earth is very rare. It's very, very rare to get. All these conditions have to be satisfied. And this inclination really helps because here you can see the lower part is receiving a lot of direct radiation. The upper part is away from the sun. So it receives less radiation. That is why we are having what is called the snow caps. If you see the polar region and the Arctic region. There are both Arctic and Antarctic from both sides. They are having always snow only because they never receive sun radiation enough to melt that ice. The temperatures are always less than zero, minus 40, minus 30, like that. So because of that, all those will be always under snow cover. And as you come further, when you come to the equator, it becomes heated up. And India and all is some of the most heated up continents, but having the maximum vegetation also. Next slide. I just want to give an idea of the weather, okay, before going to the climate and climate change. These are the interesting parameters which we measure in the atmosphere. Like you measure now when you go to the hospital, they measure all your BP and the thickening in the blood and what are the things available like that. The atmosphere, when you want to measure pressure, temperature, wind speed, wind direction, relative humidity, all these things you are aware of, evaporation, visibility, sunshine, cloud heights and all that. Sorry. And you can see the instruments which are used for doing this. Simple thermometer, you know very well. Simple thermometer, just mercury is there and that expands in the heat with it. And that can measure very accurately the temperature up to 0.1 degree centigrade. Then this is the radiation sensor. The second one to the left is the right to the radiation sensor, which India is one of the best in the world. Making this radiation sensor, we are one of the best. So what it does, we have got some system of a glass system, which concentrates the solar rays coming and focuses it on a sheet. And that actually gets heated up. From the measurement of the heat, you'll be able to know how much is radiation is falling. So every day you are measuring the heat, the radiation, especially in the winter season, it will be much less. Summer, it will be more. And during the rainy season, again, it will be between these two. And the third one, last one, which is you can see here, is the pressure. Pressure is very, very important because the whole atmosphere, you know very well, is up to about 50 kilometers. And we are actually in that atmosphere. That's why we are not feeling it. Like the fish in the water, you not see there's water. The pressure of the water is not seen by the fish. Whereas when you go to the water, when you go deeper and deeper, you will start feeling the effect. Something is pushing you and like that. Like that, since we are in the atmosphere, we don't know about it. But the atmosphere is very, very heavy. You see how many molecules are there, how many particles are there at this much kilometer height. Since we are getting that pressure in all parts of our body, they get balanced. And to measure that, what we do, we have got a evacuated chamber, you can see here. And when the atmospheric pressure acts on that, when the pressure increases, it will push that chamber and this needle will move. When it is less, atmospheric pressure will go up and this thing also will move up and like that. So depending on the pressure movement, I am able to see very accurately the atmospheric pressure. Next slide, next one. Yeah, see, these are some more instruments, very interesting. Actually, sometime what I feel is, out of you can probably go to the Indian Meteorological Department. This is in the Palace Road. Palace Road, it is there, very near to the Majestic, no? Actually. There, actually, every day they release a balloon, make all these measurements. Very interesting science is there behind this atmospheric measurements, like I tell you. So the top one is actually the wind measurement. Earlier, they used to have only a three wheels like that to just rotate, and it's connected to a rotating system, and you know how much speed and all that. But now they are all gone. This is actually an ultrasonic wind measurement. Ultrasound is called ultrasound. What it does, ultrasonic waves are sent. Ultrasonic means sound waves at about 20,000 cycle. And when they are sent, the wind actually, if it is more, it will affect that. If there is no wind, it will freely move. So whether it freely moves or whether it's moving with difficulty, that is measured within this. And from that, we can measure the wind up to 0.1 meters per second. Very accurate, 0.1 meter per second. And these instruments will never be affected even by a cyclone. Even with a cyclonic wind of 200 kilometers per hour and all, these are very stable. They just remain there. They just move direction only, that's all. Otherwise, these are not affected. So nowadays, we get very good wind measurement, even in the cyclone. Earlier, we have never measured what's a wind in the cyclone because everything gets broken. Even an instrument you keep, they will be taking away and flown. But these instruments are able to withstand that. Third one, we also want to know the third dimension. When you talk about atmosphere, X, Y, and Z. Z is the height. How will you measure? Now, somebody cannot go on keeping a ultrasound and go around and all that. So we have got what is called the balloon. These balloons can go up to about 20 to 30 kilometers. Up to a height of 20 to 30 kilometers, they can go. And you can see the red thing there. That is having the instruments. The instruments are actually not like this thermometer and all that. They are all electronic hygroscope, then thermistor. Everything measures a current actually. Depending on the parameter variation, a current is measured. Even wind also. Wind is measured from the movement of the balloon itself. This balloon will be moving only in the direction of the wind. As it goes up and up, its direction will change. All this can be measured, and then we plot, and we are able to know the atmospheric condition up to about 30 kilometers. We also measure the greenhouse gases and all those ozone, all those things. Very interesting, lot of data we get. And the other side, you can see the rain gauge. The rain gauge is nothing but a bucket. We call it a tipping bucket. But these are not the actual bucket. So you keep a bucket, I keep a bucket, and you keep a bucket and measure, the rainfall will not be same. Because the bucket which I keep may be lower surface area. You may have bigger. So depending on that, even though same rain has fallen, I will measure so many thickness only. You will measure different. So these are all what is called as the standardized 7.5 centimeter square should be the area. That's what the condition. And then once the drops are falling, electronic system is there, like a bucket. It keeps on moving up and down. And every 0.1 millimeter, means a few drops we are able to measure, and we get a record. And this is now there about 6,000 rain gauges only in Karnataka. Karnataka is one of the most advanced state in the area of weather forecasting and weather applications also for agriculture and all that. So basically 6,000 stations, and the entire country, if you see, 20,000 and all stations, such stations are there, and these balloon stations and all that are there. Next one. Okay, now these are all in the ground. What you can do in the ground, get a lot of data. And as I told you, temperature is very important, pressure. Then we have got the rainfall and all that, cloud conditions, humidity. Humidity is very important. Suppose a dry area like a desert, very high temperature, but no rain is occurring there, Rajasthan. Same thing, you come to the other side. So in India, if you see, on this side is Rajasthan, just opposite you go, you got West Bengal and all that. Every time raining only, because the same heat there also, but there actually water is there, plenty of ocean is there, conditions are there, where the clouds are forming and heavy rains are occurring. So a small change in the geography changes the entire thing. And see what we are told, I'm just telling you, this is called as paleoclimatology. Paleo means what happened several thousands of years back. There was an Indus Valley civilization, INBUS, Indus Valley civilization, in the present Rajasthan, Haryana, Delhi, up to that. And earlier also almost up to Afghanistan. Pakistan also is covered. There's a big Indus Valley civilization was there. You would have heard about Harappa, Mohenjo-daro and all that cities. They have got best things. When you dig, you are there getting lot of artisans, materials, kitchen materials, pipes and other things, water management, everything was there. Such a rich civilization, and lot of very good articles were written, Vedas were written, many things were written at that period. This should be about 20,000 years back or something like that. Then where it went? If climate change has happened. Over a period of time, those areas become deserts. It's called desertification. Those areas become desert, the Afghanistan and that areas become rocky and all that. In Pakistan also semi-desert conditions. So basically the climate change can totally remove a whole evolution itself, whole civilization itself has been removed. And such things happen in Africa also. In Africa also there are many such areas where this type of climate change has totally removed the civilization from there. Then we'll get back to that a little later. So here I'm now coming to the most modern tool for measuring of the atmosphere and weather and all that, the satellites. And this is our own satellite, METSAT we call, meteorological satellite. And this can give pictures like this. See, it can have three what we call as channels. The channel, what I mean, I'm adjusting my camera to read only the radiation. I'm not going to very detail. Physics and all is quite complicated. Yes, basically, this is the visible picture, the first one. Visible means what? What our eye can see. See, our eye can see all the visible region, isn't it? That is VIBGY or what you call that region. Violet to this one, green, like that. Whereas, violet to red. When you talk about thermal, the second one is temperature radiation. What's the temperature coming from the earth? Some places are cool, some places hot. That also we can measure. I'll tell you why we are taking these things. Third one is the water vapor. Water vapor is 6.3 micrometers radiation. And this is thermal is 11 to 12 micrometer. Visible is 0.6 to 0.8 micrometer. So we are able to develop such cameras. Actually, that's also a big achievement by ISRO. And our own satellite, we are able to get this data day and day out. So this satellite is always there over our India. Like 2 satellites are there now. They're continuously taking measurements. So you can see the little interesting thing. Same picture you see. In the other one, you can see many clouds. The second one, you can see only some areas with white. That shows only those clouds are very potential. And the third one, when you see a lot of water vapor, you can see. So by putting all these 3 things into a computer, I'll be able to find out which are the clouds most potential for rainfall. And I can also calculate the amount of rainfall also. So we make many products are made from these satellites, like rainfall, what's like rainfall forecast, temperature, where hot wave will be there. All these things we're able to do because of this picture, this type of satellite data. And this we get every 3 hours. We can, if you want, we can make every half hour also. But we don't want to waste the satellite this thing energy. So we use actually every 3 hours we get these pictures. Next one, next slide. Yeah, now we'll do just a picture. See, climate change means how many components. I just want to tell you how climate and weather is formed. You can see here radiation coming from the sun, which is simple. Simple means in the sense lot of radiation is coming, but even in that also, in the sun radiation also, there are many components. I'm going to tell you now that one is a thermal component. For example, you sit outside the sun. After some time, you feel hot, isn't it? You come inside. No, I don't want to sit there. Or you go to a tree cover shade, because direct sunshine, the thermal component is maximum. Then there is a thermal infrared, which we cannot see, we cannot feel. But our skin will be tarnished, black color will come in all those things. Then ultraviolet is there, infrared is there. Even little X-ray, cosmic rays, everything is there. That means the sun's radiation is having all components of the electromagnetic radiation at different percentage. The highest percentage is in the thermal. Now this thermal means what? Energy. See, when I keep something in a vessel in the stove, what energy I'm doing? I'm using the thermal energy. And that is heating that thing, cooking the food, then we are eating and all those things. Even our body, they say it's like a thermal thing only. That heat why we are maintaining is at that temperature only all these reactions can take place. Digestive reactions like acid, alkali, and all that thing. Then only we can actually assimilate the nutrients of the food. So basically, that's also an engine. Like that, the earth actually how it works. Whatever radiation is coming, some comes to the earth, heats up. Some comes to the water, evaporation. Some comes to the ice and other things. Then actually the snow melt will be there. And then in some cases, atmosphere itself will collect that radiation. Atmosphere itself will get heated up. So all these things happen. After that, from the water, these clouds are formed, depending on the heating conditions. And most of the water is in the either lakes or the ocean and rivers. So these are the major things which are giving the this one water vapor. And this water vapor goes to the atmosphere, and they don't actually rain there. Interestingly, had they rain there, we would have been still in problem, because most of the vapor is coming from the ocean, but they have to move. That's where the wind comes into picture. Wherever pressure difference is there, the winds will start moving, bringing these clouds. And if our area is sufficiently good, that all the clouds will come, condense, and the rainfall starts. So basically, it's a big cycle, energy cycle, with embedded hydrology cycle, cloud dynamics, rainfall, and so many other things. So any of these things, any change happens, it can affect all other things. Suppose the temperature becomes less, evaporation will be less, clouds will be less, rainfall will be less. You see? So it happens. So basically, all these parameters are interlinked through a model. So I will be talking about that little later. I will show you the model also, just for a sort of sensitizing you people. That's all. Because each of this area, we can talk for 1 hour also. That is there. Next one, next slide. Yeah, see the beauty of the God's creation. Beauty, I will call, because can anybody do this? You see the atmosphere, how it has picturized so many clouds. Very interesting. You see here, some clouds are like this. Some are like, just on the tree or just come down. Some are actually giving a halo, a circular thing. And some are like, cabbage, like we call it as cumulus clouds. And some are like stratus clouds. So basically, what we have seen is the cloud, the shape, and how much water it contains depends on the atmospheric dynamics. If the atmosphere is very cool, nothing happens. There cannot be any rain, nothing is possible, because the clouds cannot go up itself. A buoyant atmosphere is required. That means with height, the temperature should be warmer. A warmer atmosphere, what happened? I send a bubble which is going up. Like balloon, I fill balloon with halogen. Halogen gas is lesser than the other gases. That is why it's going up. So in the balloon, just a release, what happened? It is not remaining there. It goes up. Why it goes up? Because it is finding the atmosphere around it is more dense than itself. So it goes up. Like a bubble in the water. And a bubble in the water cannot remain unless it reaches the top. Like that, these clouds are actually formed in atmospheres which are having such a condition. That the thermal condition should be such that as you go higher and higher, temperature is warming. But after that, it becomes cooler also. So there is a tropopause, we call it. After that, no clouds can develop. And that tropopause height is between 10 to 12 kilometers. Over India, it is 12. When you go to Europe and all that, 7, 8 or 9 like that. So basically what happened, the tropopause determines like a lid. For atmosphere also, there is a lid is there. These clouds can go up to that only. Another thing about these clouds are, how it is seeing is the dynamics. That means, have they grown very fast or have they grown slowly? The last picture you see, slowly, lazily, they are just calm and they are spreading. Whereas the other things are all very fast growing. And these which are fast growing are the dangerous ones. Thunderstorm, lightning, heavy rainfall, they are called as convective. We will not go into very details of those things. And these are the type of clouds we come across in the atmosphere. And over India, most of the clouds are actually cumulonimbus. That means lightning, thunderstorm, and heavy rain. They are the clouds you will see, except in the winter season, some stratus, like a sheet will be there. After some time, when the sun comes, they evaporate and they disappear. Next one. Yeah. Now let us come to the global change. See, these words are little loosely used actually. Global change, some people call climate change. Basically, what we are talking about is from the present situation is something changing significantly, which with the data I can prove like that it should be. Without proving, simply telling, oh, last year there was a heavy rain, climate has changed. Sorry, that's totally wrong. You cannot tell like that. Out of 30 years, from this year, you take 30 years back. And last year, 30 years back. Like that, you have to go on iteratively doing 30 into 30 like that. Big, this metrics. In that, you find a tendency. I will show you those things. So basically what happened, that only we can call it as climate change. And there is a IPCC, Intergovernmental Panel for Climate Change. Intergovernmental means all countries are joined together. So this one area like health, you know about health, every country joins. Like the corona came, it didn't spare anybody. No, only Europe I will trouble. No, everywhere. India also it came, Brazil also it came, so many people. So basically how you manage it, that is very important. So climate change also is like that. It is going to come to every country. Let us not think that only America and all, some changes will happen, let us worry about, not worry. We will also be affected. So the smartness and the intelligence lies, are you prepared for that? Your agriculture systems, have you changed? Even your food system, sometimes you have to change. Suppose less rice is available. Will you be getting from outside? Very costly it will be. Instead of that, change over to some other ragi or this thing, or go to wheat. So we may have to go think of all those type of things in future. In the coming, I will say about 50 years, 40 years, this is going to happen. But very clear signals of climate change has already been seen. We ourselves, in our last 10 years itself, how many floods have happened, how many cyclones have happened. Everything is increasing. And the extremity of weather is very hot weather. Even places like Bangalore has become very hot. And they say, no, only because building you make. See, I am telling you the scale of phenomena what we are talking about. Humans cannot touch the weather phenomena, I am telling you. Because we cannot, by building two houses, we cannot make the place hot or cold and all that. But we are adding many aerosols, we are adding greenhouse gases that can affect. So atmosphere, if you change only, is going to affect. Not by running around here. I had a big Olympics, so change weather. No, that are very short term. It will go away. The actual atmosphere and atmosphere changes only can cause this, but humans have done that. So I'm going to talk to you about that now. Now let's slowly move to the climate change part. So now you are aware, I feel, quite well what's the weather, how it phenomenon is formed, and what are the factors which can change it. Basically, atmosphere and ocean. See, ocean temperature increase is also very dangerous. Any simple little change of ocean atmosphere, but they are shown by about half degree to 1 degree. Now it is average is 32.1 degrees centigrade. In the bird, if you take 32.1 degrees centigrade is the average. But suppose it changes to 32.8 or 33, what can happen is lot of cyclones and lot of rainfall because evaporation. And they are telling about 1/3 of the whole world's land will be submerged. Many of the islands will not be seen at all. All Bangladesh will go, for example. Around west and east coast will be underwater. Sri Lanka will not be there, like that. So that is the type of danger we are looking at now. Okay, staring at the things. Now you see here, what are the broad causes of climate change? The scientific point of view, I'm telling. Orbital variations of the Earth's orbit. Suppose Earth orbit, I say 23 and a half, slightly changes. All these areas will be affected. See, instead of this, slightly changes. But is it possible? Can anybody do it? It is happening because you would have seen this top, when your children used to play with top. When the speed decreases, it will start moving in bigger circles. Have you seen? When the speed is very high, it will be beautifully rotating. When the speed is changing, so if the atmosphere, the Earth's speed changes due to some reason, gravity or whatever. But as of now, we are not seeing any signal. Second one, volcanism activities. Okay, every volcano brings out a lot of energy, but we are not seeing any volcanic activity. Nowadays, in the whole Earth, if you see, very few areas, Fiji Islands or in Japan, some part, like that only. There's no volcanic activity at all. So this also cut off now. Plate tectonics. This is what causes the earthquake and all that. That is, what is the idea is, like I told you in the beginning, the whole Earth, this atmosphere is like a skin of the, apple. Yes, but the Earth's top layer is not one plate. Nobody can make also. See, football also you would have seen. Many segments are stitched, isn't it? The football, normal football, soccer ball you've seen, nothing is so perfectly round. In one leather, you cannot make it. You would have many leather pieces or external shape that you're actually stitching nicely and making a ball. Earth also is made of many plates. See, for example, India itself, there are two plates. One is the southern plate, other is the Himalayan plate. And the Himalayan plates go up to China, actually. Not only Tibet, even Nepal. So what happened? Anywhere there, earthquake means Delhi also is shaking. You have seen that, isn't it? But south shaking, we are not seeing much because we are not connected to any plate. So like that, there are so many major plates around the world. So that also can cause this problem. Such large earthquakes, many places, lot of energy is released. But that also we have seen, not any big activities are there. Earthquakes are there every year, 2 to 3 big earthquakes happening. Several people are losing life and all that. But we are not seeing any changes in that. Then the last one comes. Very gentle fellow, but troubling us in a big way. Human anthropologic influence. I'll explain to you. Human means, we are all the people. Anthropogenic means something changing the nature by doing something. We are doing something which is changing the nature. What is changing the nature? It all happened with the industrialization, which has started in UK and other countries. They started making mass scale production, and doing that, they actually release a lot of gases. And at that time, we don't even know these gases can be of any significance. Carbon dioxide, sulfur dioxide, nitrous oxide, methane, all these gases, fluorine gases, CFC, once PFC was there, chlorofluorochlorides like that, very dangerous. Now it is banned actually. The whole world, they are accepted and banned it because it was so much damaging the ozone layer and all that. So all those, I'm just giving a typical example. This is one of the research stations in the ocean. Because in the land, when you measure, problem is some other industry will be there that also will be releasing something. So what you are measuring will not be pure carbon dioxide. It's some other reason, somebody cooking food, somebody burning, all this will come. When you go to the ocean, perfect ocean, inside, this the Scripps Institute, this one, very good. You see, they have got many such stations over the oceans, Atlantic, Pacific, Indian Ocean. And they have taken the data and plotted. You see here, from 1960, the industrial revolution started. Exactly, carbon dioxide have gone many times. You see here, 300, just about 310. Now we are 380. Okay, that means not in percentage, you should not worry about percentage. One carbon molecule, I want to just tell you, is able to capture thermal energy 5 times more than any other molecule. And the CFCs were able to capture 50 times. That is their problem. So that is it ban. Even carbon we have to ban. Probably we don't know, or reduce it. So most of the discussion is how to bring it down. How to bring down this, at least not bring down, keep it at that level. Now, how carbon will affect something, you will be surprised. Or how sulfur dioxide will affect. That is where there is a concept called the radiation balance. There is a incoming radiation which is coming from there, from the sun, and the outgoing radiation which is going out of this earth from several parts of the earth. Like the lakes are there, ocean is there, land is there, deserts are there, snow is there. From all these things, radiations are going out. So there was a very nice balance over the years, and that balance was maintaining the atmosphere properly. But once we started putting these molecules, I'm just giving here carbon dioxide, but even carbon is there, methane is there, CH4, all those things. Each of them can heat actually the atmosphere. So what happened? In the lower layer itself, once you heat the atmosphere, clouds will not form. In the beginning, the clouds will go up. After that, you see cool atmosphere. The lower part of the atmosphere called boundary layer, that is affected by all these gases, greenhouse gases. Boundary layer can be up to 1 kilometer, specifically theoretically, but it can go up to 2 to 3 kilometers. And this 2 to 3 kilometer cloud is not forming, then how cloud can develop further, isn't it? So basically, all these fellows are these clouds, these parameters, these gases, they are straight away affecting the atmosphere thermodynamics. Thermodynamics is part of it. So with that, what happens? The cycle, you are affected the rainfall cycle, climate change and other things are happening. Second thing, it is also heating the lower atmosphere. It is also heating the earth itself. You can see that. I'll be showing the slides. Next one. Yes. Now what is the effects? Okay, just suppose that it becomes warmer. The earth becomes warmer. It is inconvenience for all of us. See, 1 degree more means you have to put the fan more speed, or you have to go for AC and all that. Or you have to take bath 2 times. All those things may happen. But drink more water. But that is all the human part of it. But what is happening to the overall atmosphere? Extreme heat. The heat condition what is already there. This year itself, we had very extreme heat conditions. Entire North India was sweltering. And in Europe, first time they are telling in so many hundreds of years, highest temperatures were in the winter months, highest temperatures were recorded. And people were most of the time sunbathing and all. No, not sunbathing. They're taking bath in the ocean and they bathing this thing and all that. Because those people cannot even have that experience. See, we are going through all these hot conditions and all. For us, it's very easy. But in the Europe and the USA and all that, even a 1 degree centigrade change will be very, very severe for them, for their body itself. They will not be able to, so they have to be in water and they have to take care of so much of cooling and so much energy. They have to spend so much energy, for all those things. So this extreme heat which is coming up is recorded. Actually, it's recorded now. Several stations around the world, the last 5 years have recorded highest temperatures. In fact, this year, highest temperature has gone up little higher also. Second thing is changing rainfall patterns. You know very well what has happened this year. Very extreme rain was quite deficient most part of the India, and it was raining heavily in the northeast region and all that. Totally, the rainfall pattern has changed, and rain should be happening in Kerala and to partly Karnataka also, and further Goa, Maharashtra, and all that. The rain was actually happening much far away in those areas, and everywhere it's deficiency only. If you see the Indian Meteorological Department rainfall maps, you can see that. Anybody can go and see that. imd.www.imd.gov.in. Very good information is there. You can see that. Now, changing rainfall pattern is actually well recorded thing. It has happened over the years. It's happening. The large scale droughts, like in Karnataka, 80%. Present, I am actually a member of the advisory board here, and what they are telling, about 70 to 80% of the state is under drought conditions. Farmers are not produce anything. Everything went dry. Water is not there. No rainfall. You know about the famous Kaveri problems also. See, if it rains well, we can give them, and we have no difficulty. And there is no rain, but you still give means problems start. And that's the condition now we are in. So basically, large-scale droughts also happens. Then falling groundwater level, yes, it has happened over the years. We are using the groundwater, but if we are not replenishing through the water, rainfall water, then that will affect the this one, affect the availability of water. So that is happening in most of the cities. But forget about the city where a lot of people are there. Even in the rural areas also, the groundwater levels are going down. I can take some more time, no? Is it okay? I have a lot of slides. I hope it's okay. Yes. So groundwater levels are also across the country. It is down. Then agriculture production. So even a 1 degree change they have shown, the paddy crop will be totally affected. 50% loss. Production will 50% loss. Paddy does not need that much heat as water, whereas wheat will increase. It will increase in the production there with 1 degree. And there are so many other crops. Each one we have identified now and calculated our agriculture departments, and they know now the 1 degree, 2 degree, 3 degree changes, how it will affect our agriculture in a very, very bad way. And next is sea level rise, very dangerous thing. And coastal areas. Already we are seeing this. If you go to Badkal, some of the areas in Karnataka or in Kerala, Calicut and all that, or if you go to Bombay, any other area, water is coming in. The sea level has already, I will show you some satellite, it's actually measured, and we are actually seeing the effect of that. And if the sea level starts coming in like this, we lose a lot of our coastal areas. Most people will have to come inside. And our 50% of our population is in the coastal area, India and all, because fishermen, other people. So we have to take care of them now. They will come inside, their land has to be given, and all those things. Then impact on health. As you understand, less rain, more rain, everything will affect the health condition because new type of germs, new type of this microbes will develop. Then frequency of floods and cyclone, definitely we are seeing it has changed. This year, for example, we had 4 cyclones. It has never happened. And 2 cyclones went to Gujarat. The beginning itself, it has also never happened. Never it has happened. Only in the towards the December it will happen. The beginning itself, by about May itself, there are 2 cyclones which went to Gujarat, and a lot of destruction and all that. And again on this season also we have cyclone. Again summer will happen. Another 2 months are there. Next one. I'll go a little faster. Next one, please. Next slide. Yeah. So now we have to actually scientifically prove that is climate change happening. So for that, one is the study of the global temperature data. We are sure that the temperature has gone up. Next one, greenhouse gases. You are telling so much about the greenhouse gas affecting. 1 minute. Greenhouse gas affecting, have they increased? I'll show you some slides. Third one is the weather itself, is it changing or not? Next one. Next. Yeah, here you see the temperature. See, we are measuring temperature up to 1 lakh sites, 1 lakh stations, the whole world. And that is fed to a computer, and that is analyzing it. Don't think that just or Bangalore I measure and I tell, oh, temperature has increased. Nobody will accept it. The area average, space average, time averaged. These 3 things you have to do, and scientifically we have to prove that it has increased. Next slide. I'm not going into details of this. Next one. Yeah, you can see here how beautifully the picture is showing. From 1860 onwards, temperature trend is towards the higher. See, there may be some year when the temperature has gone down. That is part of the natural cycle. There is a cycle you can see here, a wave-like thing. In that wave-like thing, there is a projection. So actually, they can project now for next 10 years. So what they are telling, next 10 years, temperature increase will be about 3 degrees. 3 degree more than what we are having. In another 10 years, 6 degrees. You see now, for example, in India, the highest temperatures recorded is in this one, Bikaner and all that. In Rajasthan, there is about 46 degrees centigrade. And another 6 degree you had 52. Can anybody live there? And even our own area also, 6 degree increase will finished. We will not be able to survive. So this is going to be a very dangerous situation here. Next one. Yeah, you can see here the greenhouse gases. See, all of them are showing the increasing trend. All gases, whatever gas you take and analysis is done, they're all showing the, and with that they have done simulation. What they have done using these greenhouse gases, they have actually calculated the atmospheric radiation, thermodynamics, and found out what should be temperature. And they are matching very well what we measured and what they. So these are all very good developments of humans. That is, we are now able to calculate the temperature. If something happens like this, what will be the kind like that. So that level we have come now. Next one. Yeah. And land and ocean. See here very important thing is land only is increasing? I had to prove for ocean also, because the whole world 72% is water. You know that 72%, and remaining is only land. So just by measuring the land, I cannot say, oh, whole earth is farming. Maybe only land may be farming. No, you see here the picture is much more clear when you talk about this thing also. When you add the water also, the temperature increase is much more actually, and very dangerous actually, because as I told you, small changes in the ocean. First of all, you know very well, most of you science and physics and all, the capacity increases, heat capacity. It can store much more energy and much more bigger cyclones can come, number one. Number two, their whole expansion. The ocean itself, because water, when you heat, what happens? It expands. So this also will expand. And the ocean, if it expands, where it will go? It will go to the land. And the land areas, coastal areas will be inundated. So one scenario, very dangerous scenario is even a 1 to 1.2 degree increase. It has been shown that the Bangladesh, all of Bangladesh will not be there. Then there will be no country like Maldives, no country like Mauritius, Sri Lanka will not be there, Fiji Islands will not be there, Hawaii Islands totally finished. You see, and the amount of number of people you think about them, where they will go, they become climate refugees. The future they are taking no fighting. The fighting refugees will be very less. Due to the climate, people changing, running away, that is going to increase. So that's a big burden on the Earth system that's going to come up unless we stop this. So how to stop, and I will just tell you in the end actually. Next one. Yeah. Now you can see this very interesting satellite. There is TOPEX Poseidon. They call it altimeter is there. This altimeter what they use in the aircraft and all that. No, before landing, let's see even up to centimeters height. The tire just before touching, they can see. Then they put the brakes on it. If they put brake before that, there can be danger. So they have to put the brake only when it's just going to touch, not touch it also. Just so to know that they are using the this one laser, this altimeters with laser only, of course. So these altimeters are put in the satellite, not by us, this European satellite, but it has made very good measurements of the ocean. Ocean also about 1 lakh points they measure, take the average. You see a beautiful picture here. 100% it is showing about 3 plus or minus 4 millimeter per year. Very, very dangerous. 3 millimeter, you will think, hey, this is so small, what is that? But in another 10, 15 years, that will happen. Few centimeters and then meter is going to be, as I told you, 1 centimeter increase dangerous. So in about 10, 12 years is going to happen, this one. So that is what they are measured and they're continuously measuring. India also has got some satellite. Here all together we are working to develop the systems. So now we are almost very clear. Climate change is happening. There is a change in the climate system. There's a change in the weather system. Now, two ways are there. Stop it. Stop the climate and weather changes, or adapt to it. See, there's adaptation possible. Okay, that will happen. But the problem with adaptation is that continuously going on adapting. Another 2 degree, another 1 degree, another 1 degree. A state will come and the whole world will be a desert. People have to live in desert only with drinking the ocean water. It should not happen, I feel. But if you simply adapt only, so that is where the scientific thing comes up. Can we modify these things? Now, what is the problem of all these things? Basically, we understood two things. One is the greenhouse gases. You add a lot of greenhouse gases to the system. Second one, which is actually in the underground, it's not seen, is the greenery. See, we never know that the greenery is playing a very big role until we put that greenery, that what is the amount of forest and trees and all. Now we are putting in the climate models. We found a big difference. If you can increase that by another 50 to 60%, to take care. That's what they have seen. 50 to 60% Greenery means greening of the earth. Every house, some 2 trees, so many plantations. Like that, if you start, the percentage can be increased to another 50%. This is one. Secondly, industries should not release anything in the greenhouse category. Try to then and there process it and put in the water and leave it. See, for example, nitrous oxide comes from the car and automobiles. So now all automobiles are having Paris standards and all. You would have seen European standards. That means you are not allowed to put out any gas from the costly, a little costlier, but it processes. There is exhaust which comes from the car is processed then and there and removed. Everything is removed. Then only the air goes outside. So that has given big effects actually. In industries, now no industry is allowed to release carbon dioxide, sulfur dioxide. So not allowed at all because very dangerous actually. Then methane, some of the process are releasing methane. That's also now being stopped. So everywhere we are putting a control so that, for example, I want to tell a little about quickly about the ozone. The ozone, there is something called a ozone layer in the atmosphere. See, India and this our tropical region, we are not much worried about ozone layer because our skins are getting enough vitamin D and sun radiation. But in the Europe and all that, percentage of radiation is only for 50% of the year. Only 5 to 6 months they get radiation. The remaining time it is not at all sunny, snow and other things and all that. So there's a big weakness in the system itself. So they have to have this only through sun bathing and all that. So when they do this, if the ozone is less, ultraviolet rays will come and the skin cancer. So how they also discovered, very interesting. That's why he got the Nobel Prize also for that. The skin cancer was found out in most of the European countries, most of them, and USA also, large number. So it started increasing. Then they found out after a lot of calculations and all, oh, ultraviolet radiation is coming and falling on their skin. Still, they could not find out. There is a lot of, again, discussions and a lot of research. Then they found out our ozone layer is getting affected. There's a big ozone layer. The ozone layer is actually what it does, ultraviolet ray from the sun, it absorbs. It doesn't allow it to come down. That what it does is ozone, it converts into O2 plus nascent oxygen. O2 plus O. What are good? So there itself. Then oxygen comes down. Whereas if that ozone layer is not there, it just comes down straight away. That was what was happening. That is called as the ozone hole. And satellite was the one which discovered that. And after that, they started stopping all the industries which are releasing CFC 12 and 16. CFC is actually the one which can almost eat about 100 to 200 particles of this one, ozone. So with that, layer was getting totally broken and holes were appearing there. For India also it was there, but we don't have any effect, I'm telling you, because we are already getting used to, our skin is used to much more higher radiations. So then what happened? They stopped all these industries. And I'm telling you, it took 50 years, 50 years. Now the ozone holes are closed. You can see the pictures. You just ozone hole, you put and search, you will get actually. Year to year they are put. Very interesting research projects, these things. And you can see that ozone hole has been closed. So in the human history, it is possible that some particular gas which we created can be stopped. That is being used for refrigeration and all that. So now here we are using it for many industries, automobile, production, manufacturing, the fertilizer, cement, for example. Cement production, lot of things produced. So now what they are doing is they are moving to new industries. A little more costlier, of course, but you will not have this big cost of climate change happening. So that is why all countries meet together every now and then. So now the protocols have been made. Actually, 3 have been made actually in different countries, and they are Montreal Protocol and Tokyo Protocol, like that. Every time they meet, they are finalizing. Yes, everybody signs. We will have no such industries giving this particular gas. But still, I roughly put it about 50 years it will take for all these things to be brought under control and this curve coming down and all that. So till that time, what to do? We have to face this climate change. So this is where the adaptation comes. So it's a policy of adaptation and control, both together, is what the future. So adaptation means what? Less water use or greenhouse. This one, see, you would have seen in agricultural fields, particularly, they are putting some shed-like thing. Inside that, they are growing the things. They are called as a greenhouse sheds. That is, they cut off all those other radiations which are harmful to the plant. So these are different ways in which you can control this thing. So slowly we are now adapting and changing to new systems. Next one. Next slide, kindly. Yeah, these are all I am not going to very. This is one of the fantastic satellites. Mode is moderate interferometric satellite. 50 channels are there. 50 parameters you can give sitting there. All pollution, this thing, everything you can read. Anyway, you give these slides to the coordinator. You cannot get a copy of that also. Next one. Yeah. Now you see the trends. The carbon dioxide, methane, nitrogen. See, very sharp rise. We have to bring it down. It's not a laughing thing. Very, very serious matter of this one. So we'll see how we can do that. Next one. Okay, this is the balance I told you. See, whatever radiation is coming in, but it's going up. The number of clouds are also very important in this. See, clouds, what they do, they not allow the radiation going from Earth to escape. If they start escaping, Earth would have been very cool actually. That's not happening. They're allowing only some radiation to go out, some we are keeping. So we are warm. Our temperature is still 15 degree average. That should not change. So this particular very critical radiation balance is what we should worry about keeping it. Next one. Yeah, now the satellites. Just for a little excitement only, I'm putting this. This is what the picture of the satellite can give. You see, every agricultural field can be seen, where there is wheat or not. All these things. So you can see here, this is a picture of one satellite, Cartosat, Indian only, part of Gujarat. So when you get such high level data, we can study the entire Earth, we can study the entire atmosphere. That is what we are doing now. So satellites have become now the major tool for studying of the climate change. Next one. Yeah. Next slide. Yeah. This is how we study. For example, see, June to October, how the greening is occurring. Over the India is a big agricultural country now. And our produce is so much that we can feed almost all the world. That's where they're from. Another 10 to 15 years by making new agricultural, seeds and production, fertilizer and all, agriculture management, I would say, we will be able to export to almost all countries in the world. There are enough food. That much food we are developing. We've got about 4 to 5 years of food in our stocks in case of anything happening. So there's no problem for the food security from the climate change. But if you have to maintain this leadership, then you should be careful. So here you can see how it is changing, the greenery. Each green is actually the different cultivations. Actually, next one. So these are all from satellites. This flood, when large floods are occurring, we are able to even see date-wise how much area has been affected. We have put different colors, you can see here. And the one with green is the one having the maximum number of days of flood. The other areas also flood were there. After first day, it has come down. Second day less, like that. And this is in a place called Orissa. And what we intelligently did from the satellite picture, we are also adding the GIS, Geography Information System, so that the map, what you see, the city maps and all, that also I can put in my satellite. So I can see even each village. You see here, Kaki Height, some names. I'm just reading out. So these things also we are able to see. Oh, that village had so much of days of flood. So naturally, the rescue has to be more. So all these are now being used by the disaster management groups in our country to give relief, to give medicine, to give other facilities and all that. Next one. It's a revolution actually from ISRO's satellites to the data to the analysis. A very social revolution has happened in the field of disaster management, weather, management of the land, management of agriculture, in all fields almost. Now satellites watching the cyclone, you see, the cyclone I can see so well. Just in 1999, I remember, that is October 30 or something like that, a severe super cyclone hit the Orissa coast. And 1 lakh people died. 1 lakh. It was such a bad day and very difficult thing. And the same intensity or little higher last year it hit same area. 5 people died. Sit here, boy. 5 people only died. What's the difference? That 1 lakh to 5 people is the technology what it can do. The technology can save so many people because we give the correct forecast. Sorry, forecast and is my granddaughter. Sorry, so forecast and people can be evacuated from there to cyclone shelters, and their lives can be saved. So technology, how when used properly, large amount of help it can give to the humans. Next one. Yeah, this is Kerala floods which happened 2 years back. Such a large amount of rain Kerala has never faced. 44 rivers are there in Kerala. In spite of that, the flood happened means the amount of rainfall you can think of. This is a typical case of climate change scenario. In a climate change scenario, you will see like this. Large amount of floods. There again, the satellites provided the flood maps with the names of the places also. And rescue and relief teams went there. They could go there with helicopters and other things. Saved several number of lives. They could provide them food and facilities and all that. Next one. Yeah, this is a drought condition which happens in the Karnataka. So this is actually vegetation mapping, we call it. That is how much vegetation is there, what is happening. So continuous mapping, we are able to see the red colors you can see. These are 2 years, 2000 and 2001. You can see which are the talukas, 176 taluks are there in Karnataka. Each of them we are monitoring actually. And we are able to tell the names also, which are happening and where the drought has happened. So what the government can do? Bring water there by lorries and all that, water tankers. Second thing, they can provide them some other skill, like handicrafts and other thing. And some money can be provided, food can be provided, rescue and relief camps can be there, like that. So basically, this information is the fundamental to start the drought management. Next one. Next one is this is a scenario. I would like to almost come to a completion. These are the scenario in a climate change. So we have to be prepared for that. An area which was quite good and good rain can become something like this drought area. A cyclone can become more stronger and hit more number also. And floods can be more. And with all this, the global mean temperature is marching ahead. So to bring it down, once you bring it down, again the atmosphere takes some time to get adjusted to that. So we are expecting about 40 to 50 years of this climate change scenario to affect us, then again going back. So the all actions are there. It's a total global action. And here, what is our interest? Let me tell you. In India, main interest is agriculture. Agriculture, we should be able to manage well, even with the scenarios. So a lot of research is going on, new type of seeds, which can withstand some higher temperature, lesser water, all those things. And then other thing is the water usage. We should not waste water. Groundwater should be properly conserved and all that. Then one more thing we did here in Karnataka, where I was the coordinator, cloud seeding. We did for 2017 and 2019 very successfully. Clouds are there, but not raining because of the atmospheric conditions being not favorable. So we had the planes from USA, and I was giving the forecast for where to go and put the seeds and all that. So that happened actually, and we got very good reports, excellent reports from the government and the farmers. In fact, the farmers were telling, please let it come to our village and all that. They were actually inviting, they were sending message to the minister, agriculture minister, rural minister and all that. So basically the cloud seeding type of technology also we may have to use for some years. Because when a lot of cloud is there, this year it was like that actually. But government was new and they could not take any decision. Otherwise, we would have done it very nicely. So basically, cloud seeding will also help in such states like drought-prone states like Karnataka. So there is a lot of science in this, lot of activities to be done. So my feeling is actually there is a lot of research possible in this area, and many of you youngsters who are hearing to this, I think you should get locked to this actually. There are job opportunities, many, I will tell you. And all this climate data is all big data. So the AI, AI applications is going to be the biggest in this area after medicine. After medical field, this is the highest next field where AI, the artificial intelligence will be used highest. You get a lot of data how to find out the trend, what type of corrections we can do and all that. So I think this is the last slide. With this, now one more is there. Kindly, last one. Very quickly, I will. Yeah, this is the type of models which we are talking about. So land, ocean, atmosphere. These are three components getting into a global model. It's already done. We are having very good models. And the natural disasters, again, we are getting a lot of data. So can we talk about climate change? What will happen in the coming 10 years? So government, we should help. The next 10 years, we are going to have less rain in these areas. If I'm able to tell, it's a big thing for them. You can really plan. And then the other thing is adaptation to such things by the farmers, education, the things also. So this is the summary of my talk actually. Now I would like to hear from you. If any questions are there, I'm very happy to answer. Okay. Sorry for taking more time than allotted to me. Thank you very much. Very best.
Yes, sir, thank you. Yes, sir. So we got more information from you, sir. So we will do questions also. So we have Venkataman Patnaik.
Yeah. Have you got any question? You can just loudly tell, sir. Yes.
Good afternoon, sir.
Good afternoon.
Sir, this is Giridhar from Gauribidanur.
Yes.
Our country capital city, Delhi, actually facing very horrible climate change.
Yes.
Actually, in last week, government also declared holiday for those educational institutions. And
Yes.
also, we are also facing problems. In rainy seasons, we are not getting correct rainfall. We are facing main problems now. Will you tell what are the remedies to overcome these problems, sir?
Basically, what I feel is we have got very good climatology. We call what we call it climatology. Climate atlas is there. Cloud atlas is there. So we know very well every part of the Karnataka what will be the likely clouds to come. So basically, we should be prepared. One is forecast, how much rain will happen. Second, if the conditions are not suitable, immediately you should go for a cloud seeding. Because in many countries like USA, Malaysia, many of the countries, Brazil and all, they got. No, don't touch it. Sorry, my hand out is. Say, basically, many countries are having a system for cloud seeding. They got a few aircrafts and they are operating immediately. And you cannot believe actually the amount of rainfall that comes from the cloud seeding is very high. Every drop is got here. What we are doing is we are spraying with the sodium. We are spraying with sodium iodide or sodium chloride. Both are actually very harmless. There are no health effects. Sodium chloride is salt only, very small amounts, but like a spray, micro at atomic scale, we are sending it. So each atom starts now getting the drops. Then they grow and a heavy rain happens. Within 1 hour of the seeding, you will see heavy rain happening there. So this has happened several numbers, not one or two. We did about 1,000 numbers in the first year, 2017, 1,200 in the second year. So I am actually advocating that a states like Karnataka is a drought prone. We should have that type of facility. Not like, not countries like Kerala and all. Kerala and all, climate change. 1 year it will rain, 1 year it will not rain. But here, every year you are having this problem. The clouds are coming, but no rain. So we have to go for a permanent solution. Second thing, even the rain that happens, you have to forecast properly. If it's 2 millimeter, and if it rains only 0.1, how the farmer will survive? Farmer needs actually actual information, proper information. So that forecast should be also made better, isn't it? Yes. Yeah. But we are actually doing it with agriculture department. University of Agricultural Science. Yeah, that is in Hebal, and then in this one Dharwad also. We are having ISRO is working with them to make the forecast improved forecast. But one is improved forecast, another is using the clouds to get the rainfall. Both
Cloud seeding.
Yeah.
Thank you, sir.
Thank you.
Venkat, you can ask question.
Yeah.
Okay.
Yes.
So, thank you for your
Yes.
presentation. It was quite informative. I was asking that since we have had the Industrial Revolution, we have been starting to increase our emissions, as you
Yes.
said. So in one of your slides, you showed a graph on how
Mm.
spike is increasing as time goes by. So my question is that new trend has been started within called negative or reverse emissions. Can you please explain that? What is the context of this?
Basically, the amount of greenhouse gases which you already emitted or exhausted to the atmosphere, we cannot get back. That's already gone to the atmosphere. It has mixed with it. It has increased the concentrations. Now, one way of handling it is hereafter you stop. You stop further pollution of those gases. Further emission of the gases can be stopped, as I told you earlier, using some new industries, new techniques, and all that, processing and all. Second one is there are gases which can actually act with those things, react in some sense, and then absorb them. So absorbers actually, for example, carbon dioxide. There are some gases which will absorb the carbon dioxide and solidify and fall along with rain and all that. So now they are also working on the reverse cycle. The reverse, this one is
Negative.
whatever way can we handle some of those gases to bring down again the percentage. That's what they are trying now. So, but these are all actually, I will tell you, more of chemistry problems. In the chemistry in the laboratory, first you have to prove, and then come for this one. Like that, I will tell you, the cloud seeding was one such thing. Atmospheric chamber were there, and they were doing experiments in that. Clouds they form, then they use sodium, silver iodide, and sodium chloride, very fine particles, and then there was actually rainfall. They could see this. They did many times, because unless you do a number of times, you cannot be sure about the probability and this one. Then only they adapted to the aircraft model. So like that, these things also what you are telling, like sprayers will be there. They will just spray it. See here, I want to tell you a very little interesting thing of the Indian customs. See, we used to have what is called as the homam. Homam. You're all aware of it. That is, we have a fire, and then they pray something and put some things and all that. If you see those things, they are all part of this only. The gases which they emit actually are mixing with the air and then cleaning the air actually. A sort of cycle it is. That's what they are finding now. Research is being done in these areas also. So earlier times, every house they used to do it. So a large amount of that gases will be produced. But in future, maybe we can industrially do it. Some vehicle will go and spray, or aircraft will spray, so that this greenhouse gases can be brought down. The ultimate our idea is the pre-industrial area and all never achievable. Never think about that. At least we can bring down that by 50%. That will be good actually. That's what they're thinking.
Got it. Thank you, sir.
Thank you. But these are all good research areas. Kindly read more and participate.
Yeah.
Any questions? Please raise your hands.
See, what I will do, I will be sending this, the slides will be available. Okay. And my email also is there.
Okay, sir.
Anybody is interested further in discussing and, trying to know more about that and all, I am available. If I am prepared, I am at home. Sometimes I will teach and like that. Yeah.
Okay, sir. Okay, sir. Today it's a great section for us, sir. We gained a lot of information. Already time has exhausted.
I know. I think I have taken your time.
Yes, sir. Okay, sir. Okay.
Yeah.
Okay, sir.
I want to thank
you, sir.
Supriya Naika. Supriya Naika, please tell my best regards and thanks. It's a very good initiative you have started. Try to get more members. Okay, I think maybe you can put in the newspaper, local newspaper and all. I feel so that more people can attend to this. Yeah.
Only selected peoples are in that YouTube, sir. Only selected peoples in Zoom, sir. Remaining peoples are saying in YouTube.
Oh, YouTube they're seeing. Okay, then it's fine. I want, not that I talk some big and all here. I'm not telling that way. I think this initiative is so good. So many people, see our youngsters, I'm telling you, our children, see how curious they are actually. I'm so happy to know these things. Oh, climate means this. I want to actually, at this age itself, they should get excited about it, isn't it? Then
Yes.
they'll get into the field, do a lot of wonderful work. Yes.
Okay, sir.
So very best for all of you. I don't know
Yes.
any of you, but now we have become friends. Okay, please send me any email and all that for any help with ISRO, some connection project. You want to make a project, everything, whatever help I can do, definitely I'll get there. So very best, sir. Wishing a very happy Diwali to all of you.
Yes, sir. Thank you, sir. Thank you, sir.
Very best. Yeah. Thank you.
Yes, sir. I'm as a student at Bangalore University, sir.
Bangalore
Presently,
University, which department?
sir, physics, sir.
Oh, physics only. I was teaching with Nagaraja. Professor
Yes,
Nagaraja,
sir.
sir.
Yes, sir.
He's my
Kamsala
close
Nagar.
friend. Yeah.
Yes, sir.
Yeah, he was
Yes,
there
sir.
in the Sir MB chair, MB Visvesvaraya chair. Yeah.
Yes, sir. Yes, sir. Yes, sir.
Very nice.
Okay. Yes, sir. Thank you, sir.
Thank you.
Bye,
We
sir.
will meet. We'll meet and interact. Very
Okay,
best.
sure, sure. Sir.
God bless.
Okay. Okay, sir. Bye.
Thank you.
We're going to end up this session, sir.
Yeah.